Hi everyone, welcome to the stream. Yeah, as usual, I'm streaming on three sources. Yeah, but I'm keeping this chat on the side, and yeah, okay. Let me check if YouTube works because YouTube sometimes takes a little bit longer to start. Um, what the hell? All right. Okay, now it works. Actually, have been thinking about what should I include in the course, and actually, I don't know. I kind of want to do more Q&A sessions. I also would like maybe to do some pair programming, or maybe I don't know some like take some like maybe take some requests from viewers about what C++ features should I explain. I think that next week I'm going to try to figure out some sort of structure, but since I promised to do streaming well, on Wednesdays, Fridays, and Sundays, I'm going to stream something today, and it won't be a normal like live coding. It will be like I don't know, kind of fun, advanced session about C++ templates. And again, it's an advanced topic. I sort of assume that um, people here at least heard about templates and what they are. Um, and well, yeah. So. Yeah, this is because some people like wanted to see more advanced stuff on Sundays. I know. So let me know if I should do more advanced stuff or less advanced stuff. Also, so yeah, send your suggestions in chat or in YouTube comments if you're watching this offline. And well, so Steeple's last templates are fun. Originally, they were designed to do well, I know. Originally, C++ sort of evolved over a few years, and initially there were no templates, and when they were like designed, um, they I don't. They were designed to allow people to do to implement generic algorithms and or generic templates or sorry generic containers and some people after the templates were introduced, some people discovered that they're Turing complete, which means that you can basically do any computations during compile time, which is a very interesting thing. I don't know what other languages have similar features. Um, I'm pretty sure that Java doesn't have this, Python doesn't have this, and well, C++ does have this, but it has it by accident. It wasn't like it wasn't designed to be Turing complete. It just was an unexpected side effect. But sometimes it's useful. And today I'd like to show you how to do this and um, like do some pretty well, not that useful stuff. Okay, I need to mention Gerber, and I'd like to do some pretty useless stuff, like I don't know, maybe implement this button. Let me know what you want to see implemented using just templates, and here's how it works. Um, Here's how and why it works. Um, so what do we have? Let's implement a template class that has one template parameter, an integer n. Let's call it full because we need some sort of a name. And well, basically, it turns out that basically C++ templates allow you to use some sort of a shitty functional programming language. So it's really ugly. Most functional languages are a lot more beautiful. But like I mentioned, C++ wasn't designed um, to do these computations. And let's see. So let's say we have an enum here, and let's call it result. Oops. Yeah. So basically, I defined an anonymous enum, and we can now access it. We can now access result if we instantiate a template. So let's do this. Now, of course, we need to include yours too. By the way, another thing that I'd like to do today is to answer some C++ questions. So if you have C++ questions, no here. And so what's wrong with it? Oh, okay, yeah, sure. Let's do extract, which is abstraction in C++ is pretty much the same thing as class. There are some minor differences, but you can pretty much use them interchangeably. Okay, actually, let me launch CMOX. And so it's not surprising at all. So we can we can get a template parameter from template using enums, and we can actually do something like that. So we can do some computations. Guys, nothing really surprising here. And it's not very, Turing complete yet. So it's just some simple computation. So so what can we do? How can we do some more complex computations? It turns out that there are two features that allow this. Like, maybe I shouldn't call them features, more like things. So let's create another class. Let's call it bar, and yeah, let's do it enum. Oops, sorry. Now let's actually do it. Let's make it 3. Right. So we can access. Right, and we get 88. So we can access this result constant from other classes. So this is getting more interesting. Now, what can we do? We can actually do this. Let's say we can do things like that, right? We'll just compile Not really, yeah, because fatal error recursive template instantiation exceeds maximum depth of 256. Okay, so we can pretty much do recursion, right? And we can make infinite recursion using templates, which is a really interesting thing. Now, but we need a way to terminate this recursion, right? So how do we do this? It turns out that there is another C++ feature called partial instantiation. Actually, no, it's not partial instantiation. Sorry, I forgot what's its name in English. I forgot it. Maybe it's actually partial instantiation. Sorry, I need to. I should have checked this before the stream. Yeah, it's called explicit instantiation, I think. No, it's not explicit instantiation. Damn it. This is embarrassing. Let me check the chat here. Maybe some people. Yeah, 4 people are watching. Okay, I forgot the proper term. Is it? I'm pretty sure it's not partial instantiation, although maybe it is. Maybe I'm right. Partial specialization. Yeah. Okay, it's probably it. Yes, it's partial template specialization. So it's not partial instantiation, it's partial specialization. Okay. And basically, what does it mean? It means that we can choose a subset of template arguments and make like a specialized version of template, right? So it's a sort of general version of, because it works for like all ends. And what we can do is we can do this. We can make a special version of foo. I hope I remember the syntax correctly. I can't be wrong here. So that would be embarrassing because I hope that I still remember this. Let's make it 0. So okay, another semicolon here. It should be just a comma. And it works. I still do remember this syntax, and but we do get here some sort of a result. So my point here is that we have a recursion and we have branching. So we can do recursions and if expressions using partial specialization, and it's a really fun thing. You can pretty much do every possible computation during compile time. For example, you can find prime numbers. You can calculate Fibonacci numbers. It's a fun feature. I don't know. I could probably solve some sort of problem from height. So I'm mostly I mostly look only at chat on watchpeoplecode.com. So but sometimes I look at the chat on Twitch and the chat on YouTube. So I don't know if I'm explaining this clearly. Let me know if you have questions. This is like an unexpected side effect, which was discovered, I think, a couple of years after templates were introduced. And sometimes it's actually useful. Sometimes you actually need to do some calculations during compile time. For example, so when you are writing some template code, sometimes you need this feature. Like one of the real-world examples I saw was calculating the size of an integer. I'm not sure if I'm explaining this correctly. Like calculating not the size of the integers, like how many. Yeah, wait a second. How I can explain. So okay, so we have one real world example, and it was something like that. There was a class bit set, which was like a bit set, and it has like something like it was a template class. It has max value, so it's like a set, and it can store integers up to max value, and it is implemented using some bit operations. But how many features, things like that? Okay, I will answer that. So, but you need to calculate how many bits. Okay, it's not how many bits. How do I explain this? Like, yeah, but you need to calculate the size of your bit set. Essentially, it's how many bits do you need to store every number up to like max value, which is something like which is, as far as I remember, it's something like logarithm by base 2 logarithm max value, and it's not that hard to compute using templates. But again, something, and well, it's a fairly simple computation. I'd like to show you more advanced examples, which probably don't have any real world users. So, how many features, things like that, C++ has developed with Java, and it's pretty boring language, but it works fine. I love Java. Well, that's an interesting question. I'm not sure what you mean by things like that, because you can't do compile time computations in C++ without templates, and you pretty much need these templates for doing compile time computations. But if you mean like things of features that can be heavily abused to lead to unpredictable results, or like surprising interesting results, I would say that another similar feature is operator overloading. So you can do them in Rust. Okay, that's actually pretty cool. I don't know about Rust, but some languages like D take this compile time computations idea to the next level, and like D actually has some nice support without all the C++ templates ugliness. So they actually designed the language to include support for compile time computations. And well, Gerbex tells us that you can do them in Rust. I wouldn't be surprised. Sometimes it's actually really nice to have compile time computations. If I remember correctly, C++11 has, yeah, actually C++11 has something like const export. And if I remember correctly, you can write some sort of function, and const export, well, allows it to be used as basically for compile time computations. So even C++11 includes more transparent support for this feature. Again, but in C++98 there is no const export. Plus, I sort of wanted to show you like an unexpected side of C++, so that's why I'm doing this. Like I mentioned, let's do some advanced stuff. Yeah, because I also tuned my OBS to be to have much less lag. So if you need my profile, like OBS, like my OBS settings, you can use them. Basically, you go to output, and the most important stuff is here. Just set your bitrate to 2000, keyframe interval to 1. You can use CBR, but you can also use VBR. And actually, it's much better to use ultra fast. And it's important to add tune zero latency. Okay, so what should we like? What should I use? Like, what kind of problem could I solve? I guess let's go to project order. I know you can't really parse with them. You can't really do. You can't really do in IO with templates. It's a compile time feature. I don't know if it's possible to do IO. In principle, you can output things using error messages. So, for example, here what I do is the template, the computation is done during compile time, but you may not believe me because, well, I still run the program. So can we make it? Can we make C++ compiler output things? And yeah, we can, but it will look ugly because what we have to use is just error messages. So we need to force C++ compiler to output some error message that contains the result. How do we do that? Actually, it's I think that the most simplest thing is to do this. Let's say let's call it struct output. No, not really. At least in +98 has no I/O. C++11, I don't think it has. I don't think even C++11 has features, I/O features. Yeah, I'm pretty sure it doesn't. So I like so like compile time computations using the place is like unexpected features. So this isn't surprising that that what you can do with them is limited, and it wasn't designed to target like some practical applications like embedding stuff or compiling regular expressions. Actually, compiling regular expressions during compile time is actually pretty awesome. I really need to look into Rust. Rust sounds like fun. So, can you use random and them? I think that it's possible to implement a random, a pseudo-random number generator, but you can't really use like a rand function or a random. You can't do this. You can't use normal functions like at all. But again, let's do some output. Actually, never really bothered to compile time output. What the hell? Oh, I made a typo. Yes, works now. So how do we output things? Why can I do it static? Like I want to do static variables. Okay, it's compiled fine. Oops, sorry, what? I don't remember. I never really bothered to do output using templates. So let's just, I guess, do this. Let's do something like, I know. This should fail. And this should generate a lot of messages. No, that didn't work. Hmm. So, how do we cause this to fail? So we need to generate something that can't compile. Implicit instantiation of oops, shouldn't. Oh, can we? Yeah, okay. Let's go to Stack Overflow. Check out my publication. Well, it's definitely possible to cause a compiler to output an error message containing the number. So I should have checked this before stream. But for some reason I thought that should be simple. Well, this isn't interesting because they also call it during runtime. So we need to, well, let me Google this a little bit. Solving C++ is bug with C++ compiler messages. All right. I don't really remember how to do output. Maybe we could try GCC. Oops. Yeah, okay. It works with the GCC. So I was right when I tried this. So because I'm used to GCC, and as you can see with GCC, you can see the output. So so here we can make GCC to output the number, which is the same as well as it was on the console. I don't use GCC though. I'm not sure what you mean. Okay, so it's compiler. So it depends on your compiler. With Clang, I don't know how to make Clang output this, but with making GCC to output the number is really easy. Why don't you use GCC? Oh, because on Mac the default compiler is Clang. Also, well, why not use Clang then? And well, Clang has actually some nice features. Yeah, it's not. I mean, yeah, it's not clean, but it's what we have. We don't have any other way of outputting during compile time. But at least it proves that I'm not cheating and I'm not lying to you, and it actually works during compile time and not during runtime, because we can have this. Because it proves that the computation is actually happening in compile time. Okay, let's go and solve some project or the problem. It was a while since the. Okay. I know, maybe not project order. I know. Okay, let's just write a prime checker. Yeah, definitely. A few years ago, I actually solved a few problems just using C++ templates. And I actually don't know how to solve this one, but let me think. Actually, you know what? I know how to solve this. So maybe let's solve this problem. Yeah, let's solve this. So we have recursion, we have branching, and that's enough. Let's write a program that detects if a number is prime. Okay, how do we do this? So let's create a template class. Sorry, it's not class. It's n class Actually, what's my use struct? Hi. I can't. You can, but doing square root before counting divisors worked and made it faster if I remember correctly. Yeah, basically, yeah, you're right. I'm a little late. I see. Yeah, I'm actually. I don't know. Do you have some experience with C++ templates? Yeah, I've been doing this for like half an hour, and most of the time I spent explaining. Yeah, they're scary, and I'm actually abusing uh, template system to do compile time computations, which is an unexpected feature. C++ wasn't designed to do compile time computations, but when templates were introduced, uh, people discovered that they are Turing complete, and you can do all sorts of computation during just compile time. Not every language has this. Java doesn't, Python doesn't. Apparently, Rust does. Java can do that, but Java generics are not the same thing as C++ templates. So, now I'm trying to solve a project earlier problem. Uh, so, and let's start by implementing something like is prime. Okay. Oops. Okay. Let's see. Okay, this won't work obviously because 4 isn't prime. 5 is prime, but this should compile. Okay, it says 0, 0. Yeah, not true. False, false. This isn't correct, but let's do some. Let's write a helper class. Is prime helper int from int to int and this class is going to check divisors. Wow. Wait a second. Okay, so how do we do this? Like I mentioned, we have recursion. Basically, we have an ugly functional language. Recursion is here. So we can write result. No. Result equals to no. So let's write a ternary operator here. I actually don't remember about build. Sorry, I don't know about large binaries. It may be true, and in fact, it's probably true. If you use too many templates, the build time will definitely be slower. Like using templates increases build time, and you will be able to see this because actually doing compile time computation is not very efficient. So if from is a divisor by actually let's do this if n divided by 2 is equals to 0 means that if n is divisible, let me check how to pronounce this correctly. Divisible. Okay, divisible. So if n is divisible by 2, it means that the result is 0, means false. And else we are going to do some compile time, sweet compile time computations. Okay. Oops. Okay. Expected instance of checks on generic. Well, in C++ you can't do instance of. Actually, we probably can't write this sort of thing in enum, or I don't know how to do it. So let's actually use const int. I think const int should work. Maybe I'm wrong though. Let's use, static const int. Oh, wait a second. Maybe it works with enum. Obviously we need to use result here. Okay, this worked. Okay, so now how do we stop looping? Like, how do we stop the recursion? Okay, again, doing partial template specialization. Yeah, maybe you could have seen me there. I worked in Yandex, so maybe you could maybe you saw me there. I don't know. Okay, so to view template arguments for class template is prime helper. Oh, this should be enough. So we are doing template specialization here, partial template specialization. Okay, working. We can probably use this to just launch the computation from 1 to and divide it by 2. Well, there is no. It would be better if we wrote a square root of n, but we can't do this. And I don't know about. I don't know a simple way of calculating a square root during compile time. So let's do this. Respect the клетчатую рубашку. Откуда столько людей здесь на YouTube? I'm mostly using chat on what people code, but occasionally I take a look at the chats on other services. So 4 people are watching on YouTube. I'm surprised because last time I cross-streamed to YouTube, there were barely any people. Like there were no people there. Okay, so we can do this, and let's do is prime helper result. Did it work? I don't think it did. Oh, yeah, sure. is prime. It's called is prime helper. And I think it works correctly. Let's add some more. Let's check 7. Let's check 9. Let's check 11. Let's check 13. Let's check 15. And let's check 16. Well, it looks ugly, but what can we do about it? So 4 isn't prime, correct. 5 is prime, 7 is prime, so 9 isn't prime. 11, 13 is prime, and 15, 16 unprime. So it works. Basically what it does, so this template just uses a helper template. Again, we partially specialize is prime helper to stop recursion that is written here. Yeah, I mean, yes, if you actually add some support for compiled time computations, you will end up with something more beautiful than C++ templates. It's basically a really ugly, shitty functional programming language. I think I mentioned it a couple of times, but sorry for repeating myself. Yeah, let's do. So, okay. We need to find first. Well, actually, we need to find 10,000 first prime number. How do we do this? Let's create a structure called probably we need while true loop plus a counter to increase on each prime. Yeah, that's what I'm thinking. The problem here is that it's not really I mean, C++ templates are not really convenient, and you can't easily translate normal controls flow operators in. Sorry, so you can't really translate normal code into C++ templates code. So I'm trying to figure out how to do it in the most possible, so like in the most simple way. Yeah. Oh yeah, let's do this. Let's create is. How do we do this? Let's call it nth prime. So again, it's going to be, let's use a helper template, something like nth prime helper. It's going to use I need to think about it. I think let's start by writing something like um, next we will need something like that. Template int n next struct. Is it as complicated as JavaScript development? I don't know. I don't think that JavaScript development is that complicated. I mean, in a way, templates are simple. You just use partial template specialization for branching and recursion. So it's a shitty Turing-complete functional programming language, and there aren't that many syntax constructs here. High float Pascal. So let's write the next prime function. So actually no, maybe not. Let me seriously think about how the loop should be organized. I think not a number equals to not a number is false in any language. Like it's false in C++. I'm pretty sure it's false in Python. Don't throw exceptions, please. How do I even parse it? Depends on what you mean a real value. I think it's a special value. Right, so you have two nuns, and comparing them yields false. Python has nuns. So oh yeah, we actually need next prime. So let's write next prime loop. So let's return. Let's actually call it current. So if current number is prime, we return it, and if it isn't prime, we to this next prime loop current plus 1 result. So in what case would nans be useful? Well, for I mean, nans are used for representing invalid sort of. So nans are useful when you want to signal that computation so let's say you're writing a function. Let's say it's a square root function. I know, but okay, there is no square root in Python. Can I do this? Oops. Works weirdly. Okay, so let's say you're writing a square root of a function and you want to do this. You want to find the square root of -1. And the function should return something. Well, and what should it return? Obviously, it can throw an exception, but not all languages have an exception mechanism. Or what should 0.0 divided by 0.0 do? In Python, it throws an exception, but again, I think that it's a valid method of error handling. So you just return a nan, and yeah. By the way, what's really interesting is 1.0 divided by 0.0 is okay. In Python, this won't work, but in C++, this will yield plus infinity. Float 100 CPP. Let's do this. Kill him. Kill him. So I'm like an evil voice in your head now. So 1.0 divided by 0.0 is plus infinity. So there is a special number called plus infinity. Plus in minus 1.0 divided by 0.0 is minus infinity. And 0.0 divided by 0.0 is none, and if I remember correctly, this should be minus none, but I'm not sure if there is minus none. Yeah, there is just none. It isn't signed. But what's really fun is that there is plus 0 and minus 0. I'm not sure. Yeah, there is minus 0 and then there is plus 0. And you can actually compare them. I don't actually know how to compare plus 0 and minus 0. I mean, what should... I'm pretty sure that they should be equal. Yeah, it means that they are equal to each other. I wonder if infinity is equal to infinity. Okay. Yeah, they're equal. And plus infinity isn't equal to minus infinity. So let's do some other stuff. Let's go back to writing code, template magic code. So we are able to find next prime here, and to find and prime, let's do this. And prime and -1 result. The result is next prime loop. I think this should work. So what we need now is just n prime for some n, and the first prime is just 2. So okay, wait a second, we need to still type template here. Let's see if it works. Okay, we know that this prime works. Let's see if n prime recursive template instantiation exceeded maximum depth of 256. Okay. So if current number is prime, we return it, and otherwise we call next prime loop. I don't think that there is recursive template instantiation that exceeds maximum depth of 256. Maybe this is because it always has to instantiate something. So so let's debug this. I'm just writing this for debug purposes, and okay. Okay, this works, but it will work only for primes under 100, because like I mentioned, we need to use a partial template specialization to stop looping. And here I use a ternary operator that still has to instantiate this. So we need a way to terminate it. So we need a more we need a way to terminate this recursion, and I think I know how to do this. Let's pass maximum value here. I wonder if I can do this. I actually don't remember if it's possible to do this without constant. I know. Let me check it. I wonder if it's possible to write non-constant values here in this way. Maybe it's possible. I think actually it looks like it's possible. 2 multiplied by n prime minus 1 result. So here we search for next prime between so we have like a prime number. Let's call it like ith prime number, and we search between prime I and prime so we search within a range like previous prime and previous prime multiplied by 2, and this allows recursion to terminate properly. But let me check if there is actual like if it's actually true. I'm pretty sure that there is always a prime number for any x. So okay, stating that for any integer more than 3, there always exists at least y number between a weaker but more elegant formulation is there's always at least y number. So yeah, let's use Bertrand's postulate here. We can actually use it to terminate our recursion. So it's probably not very efficient way of doing compile time compilations. We probably won't be able to solve the problem because it will run out of memory. Let's try though. Let's try to find 10th prime number. Okay, it's 23. What about 20th? And it's 71. What about 200? And let's increase depth. So it's enforced by compiler, and we can and we can make it use bigger depth. Yeah, there is minus f template depth parameter, and let's use it. Let's set it to 750. And as you can see, it is really slow. Okay, let's use even bigger depth limit. Um, I'm not sure if it's possible to disable it. Also, I'm pretty sure it wastes a lot of memory, like a lot of it. Right now, how to do sorting in this sucks. I need a normal top. Normal top. Like do no top. A better top command for OS X. Okay, let's see if there is htop. Sort by. Oh, wait a second. It crashed. Unable to execute command. Segmentation fault 11. I mean, I don't know. No diagnostic message. Please submit a bug report to. Like, it crashed. It just crashed. Yeah, it's a segmentation fault in clan. Try GCC. Yes, let's try it. Okay. Sort by memory. No, okay, let's sort by CPU. And actually I can see it. I can't. Wow. Incomplete type, used in nested name specifier, template initiation depth exceeds maximum of. Yeah, this is because we need to increase, well, template depth. Actually, can't see GCC here. I just can't find it. Yeah, this is possible, but I'm pretty sure if you forgot semicolon, you will. Right? So it doesn't work for some reason. I mean, for some reason it isn't able to see. All the commands, all the processors. Did you press enter to start GCC? Yes. As you can see, it actually can detect that all 4 cores of the CPU is actively used. For some reason it can't detect that There is. Yeah, it can probably detect how much CPU G++ uses. This sucks. Um, primary key. Okay, here we can see how much CPU it uses. CC1 plus. Here it is. CC1 plus. It uses 2 gigabytes of memory. Yeah, it's not very efficient. Just to find 200 prime, we just wasted 2 gigabytes of memory. I think that it actually can be written in a more efficient fashion because I pretty much instantiate um, instantiate that much templates, all from n power 2 templates, which is a lot of templates. I think that it can be done in all from n templates. So yeah, it's really slow. It wastes a lot of memory, but it works. Okay, 4 gigabytes of memory. Right, you can see this. CC1 plus wasted 4 gigabytes of memory. Ah. I can't chat and watch people code. What am I doing wrong? Sometimes this happens for no reason. I wasn't able to reproduce this. I wonder what's the best way to do this. Try refreshing 4 times. I'll try to figure out why. It's a web socket. It's a web socket. It's web sockets using /socket.io slash just normal socket.io on the front end. Okay, let it crash. Let's just wait until it crashed. So it ate almost like 6 gigabytes of memory. Can I believe this? Or is it 2 gigabytes of memory? I don't understand. What's MEM and what's CMPRS? Yeah, but sometimes this bug happens even with people who are able to press refresh button. Yeah, there is a fallback. MPRS indicates the number of bytes, not bit of compressed data belonging to your process. Okay. So what's MEM then? I mean, clearly we can see here that MEM is just about 2 gigabytes and CMPRS is 7 gigabytes. So is CMPRS is just a total number of memory used? Let's find out. And my browser is really slow because GCC wasted all the system memory. And there are swaps. Swap is actively used. Yeah, physical memory, just about few dozens megabytes unused. So it is swapping now, and all just to find first 200 primes. But like I mentioned, it can be implemented more efficiently, but um, compile time operations in C++ is really slow. Okay, I wonder. Hope there is no problem with the stream. Hopefully it works. Active monitor torrent. Yeah, thanks. Let me check it. Let me check it out. Yeah, works. A out. This is probably some process spawned by GCC. Okay, so it clearly can't compute this number. So let's use a lower number like 15. Sorry, not 15, 50. And let's use clan. Okay, works. 70. Much slower. For some reason it gets slower. Okay. Okay, so it's prime number and it's 70th prime number. So the program works correctly. That's nice. What should we do? Okay, let me. I think that's enough template magic for today. So we can't really solve the project owner's problem, but we can solve a smaller version of that problem. Yeah, C++ templates are not very efficient. So sorry. I wonder if I should submit the crash report to Apple. I don't know. It looks. I don't think that C++ compiler should crash when it wastes too much system resources. But I don't know. Maybe this is by design. Let's actually see. Plan crashes on template instantiation. What happened? You request too much. I decided to abort it. I stopped the program. So I ran now. It's running on a smaller value, like just 100. Yeah, and it works nicely. Let's see how big is the binary. The binary is just 10 kilobytes. So it's very clearly that C++ can optimize a lot of things. So it doesn't include. Yeah, wait a second. We don't really have a lot of code here. So I don't know. So compilation time is low. The binary size is okay. And now isn't 10 kilobytes too much for prime? I don't know. I mean, it's a resulting binary size. Yeah, thanks to templates, it calculates the result during compile time, which is the whole point of writing this horribly looking code. I just wanted to show you how to do compile time computations using templates. Uh, okay, so now I'm trying to figure out if it's necessary to report the bug in clan when it crashed. Probably not. Does work with C++. It wastes too much system memory and it starts uh, swapping, and I decided to kill it. So, well, it works, but it looks like eventually it will run out of memory. Okay, so the code is working. It isn't very efficient. The algorithm is clearly wrong. What do you mean by by this? It shouldn't need that much resources. Well, yeah, I mentioned this before, but it's possible to use less resources, and but not orders of magnitude less. If you instantiate too much templates, you are going to run out of memory, and you are going to run out of memory pretty quickly. It's probably a few thousands of templates, and you're going to run out of memory. Maybe a few dozen, thousands. Yeah, it's a template thing. Templates are somewhat expensive. What do ampersand and percent do? And okay, so ampersand and percent. Let me show you. So in C++ we have something called pointers. First of all, I don't know if you can do this. So first of all, this is probably just end. So this is just end. Yeah, you're welcome. Or it can mean, or sometimes it means taking an address. Just so. What is the correct result? The correct result for what? The code clearly works, but it wastes too much resources. So it is able to find like the first 100 rhymes, but it is slow, it wastes too much memory. So C++ we have something called pointers. So let's create a variable, and this variable has an address, and we are able to take an address of this variable using ampersand. Wait a second, client plus plus. Okay, and this is an address, and well, address is just a number of like a memory cell. The best way to think about pointers is just imagine a huge array of cells, and each cell has a number, and each variable corresponds to a bunch of cells, like a continuous number, like to a bunch of continuous memory cells. And the first, for example, int occupies 4 memory cells, and the address of the number of the first cell is like the address of this variable, and ampersand just takes an address of the variable, so it's just like a number of the cell. And it's different from run to run, and that's okay. I don't think that you can do this. Yeah, okay, you can do this. But you can actually store the address in another variable, and the another variable is going to be called pointer, because it sort of points to a memory cell, right? Oops, did it work? Oh. So if you output it, right, so you can see that it stores the address of y variable. And actually, when you create a pointer, it is just like a regular variable. The best way to think about it is to imagine an integer just like y, but this integer is also stored somewhere in memory, so it also has an address. And this means that we can take an address of this variable, and we can just take an address of x, but sometimes we need to get an original value of y. Yeah, like addressception. I actually know a great video about pointers, like funny pointer video, funny C pointer video. I think I found it. Let's just let's just get a YouTube link. What about arrow operator? Yeah, I can explain that too. I know that some people have problem understanding pointers, but try to play with them. Yeah, it takes a while. Just get used to them. The best way to think about them is like imagine. I mentioned that. Imagine like computer memory is just a huge array of cells. Like it's a huge byte array, and each cell has a number, and this number is the address of this cell. And well, I think that maybe that helps you to understand this. Yeah, I think this is a great video. So we can dereference that. Right, so if we do this, we get the original value of, extra semicolon, we get the original value of y. So it's called dereference operator. So it's a star is just a dereference operator, and 2 stars is just dereference operator applied 2 times. So here we just we get like star z is just x, but but you can apply another star to an x, and this way you can get z. So essentially So these two things are the same. I hope this makes sense. I'm probably not the best person to explain pointers because I don't remember what it's like to not understand pointers. I haven't programmed for quite a bit of time. What about arrow operator? Okay, so let's say you have a structure if you're using C, or maybe if you're using C++, you have structure, or you have class, and let's call it foo, and it has some sort of an integer in it. But what about well, you can apply this, you can check this indefinitely. So you can create a pointer to pointer to pointer to pointer to pointer to pointer to an integer, right? So yeah, 3 stars is just pointer to pointer to pointer. Like it's I don't think I ever saw more than 4 stars, and 4 stars is very rare. 3 stars is rare. 2 stars are common, and 1 star is like very very common, like a normal thing. True. Well, I think that's I don't know. Actually, let's find out. Can we actually go to infinity? Let's try it. So, I don't really know. I don't know. Maybe there is some limit here. Okay, let's take 3 stars. Let's make 9 stars. Okay, now we have 10 stars. 20 stars, 30, 40, 50, 60, 70, 80, 90, 100. 100 of stars. Let's test this. Wow, apparently, wow, can we actually create a pointer to a pointer to a pointer without creating, well, 99 stars? If Alex opens the stream and points into his webcam, I don't know, I'm not sure what, I don't understand what you mean, sorry. Yeah, I don't know. I can do an exception here. I don't know. I'm pretty sure that it's either. Let's find out. Let's find out by googling. C pointer depth limit. Is there a limit? So the upper limit is implementation specific, which means that it depends on the compiler. Let's find GCC pointer depth limit. I don't think that it mentions anything about pointer depth. Yeah, it's implementation specific, and I'm trying to find if there is a limit in GCC. So I'm looking about GCC. Anyway, so there is no limit. You have. Is this what you want to do? I was just I'm just trying to figure. So Yumik asked what means 4 stars. Yeah, pretty much. But I was trying to find out how much stars can you have here. Like, can you have a pointer to pointer to pointer, 1 million things? Yeah, sort of. Yeah, there is like extra. I'm assuming that +1 means another star, and yeah, that's what I'm trying to do. But yeah, I was trying to find a limit to this, and it turned out that it's much simpler to Google. I don't think that there is a use case for that much pointers. Like I mentioned, I sometimes it's possible to. I mean, sometimes you can see 4 stars. So a pointer to pointer to pointer to pointer to something. Um, but it's really rare. Three like 3 stars are somewhat common. 2 stars are really common. It's nothing special, and 1 star is all over the place. From Stack Overflow Visual Studio, you can have wow. So 1,000. Uh, I wonder if there is like oh yeah, I know that it's pretty cool demo. I really like this. I think there was a cat pointer. I don't. I don't know. Yeah, like little elves actually pointing to things. That'd be fun. I'm pretty sure that would make programming much more fun. So, are there other questions? Wow, 7 people are watching on Twitch. Hi people if on Twitch if you have questions about C++ or maybe C or maybe programming in general, let me know. So, maybe there's what are the best C++ books you ever read? Oh, so the best C++ books. I think that thinking in C++ is a really great book for beginners. So Bruce Eckel wrote 2 books called something like Thinking in C++, and there are basically 2 volumes, right? Oh yeah, that's true. There is a huge list on Stack Overflow. Um, So a very dumb algorithm in C finds an answer in 6 seconds. By the way, yeah, I'm not surprised. I actually didn't like the Bjarne's book for some reason. So yeah, I think that thinking with C++ is great for beginners. So it's a great introductory book. Templates are really effective. Expensive, yes, they're really expensive. Scott Meyer's books are also great. I don't think that they are suitable for beginners, but once you get used to C++, you should definitely read those. They are awesome. More effective C++. It's also another great book. I mean, I don't remember about effective STL, but effective C++ and more effective C++ must read. I think that exceptional C++ and more exceptional C++ are also must read for C++ programmers. My first book is loved by you. I don't know. Maybe because I wasn't a beginner when I started reading it, but to me it seemed like it's just more like a reference manual. So it's good when you want to look at the description of a specific feature, but it's not a great book to read from cover to cover. I think it's probably good if you want to just open it at a random page and just learn about that feature. But there is like no narrative. it's more like a reference manual. So what other books I can recommend? Yeah, Herb Sutter is great. I haven't read this book, but I'm pretty sure that it's great. C++, it's about the new C++, which is C++11 and C++14. I think that Alexandrescu wrote great books. Modern C++ design is a fairly advanced book. Um, so when you have quite a bit of experience with the book, and if you like template stuff, you should definitely read this book. It's all about templates. Think it's not. I think it's not only about templates, but half of this book is like just about weird shit you can do with templates, and not just weird shit. It's just actually nice, useful things. Oh, yeah, The Design is Evolution of C++ is an amazing book. I don't recommend reading it until you have like a year of experience with C++. Also, maybe you should read it. I don't know. I've read it after I had like 2 years of experience programming in C++, and I really enjoyed it. It explains why C++ is the way it is. It's okay, very nice. I can't really comment about other books because I haven't read them. So if you're a beginner, start with Thinking in C++, um, by Bruce Eckel. Yeah, like and once you program a bit, you read this for like, read 2 books by Scott Myers and 2 books by Herb Sutter. Maybe 3 books. I don't actually. I think I read these 2. Um, I heard good things about this book, but I haven't read it. Are there any free C++ resources you recommend for beginners? Um, Aside from pirates and books, what could I recommend? Uh, yeah, Google. There is CPP reference. It's not really. How do I put it? It's not really a resource. It's more like a reference. It's great when you want to read about specific C++ feature. Just for example, look at what methods vector support. Support vector has. Um, no, I didn't read a lot. I didn't use a lot of C++11 features. Sadly, I don't have much C++11 experience. Um, let's take a look at this. Oh, wait a second. I probably, sorry, it's actually, I think I very occasionally use CPP reference. Most of the time I use c++.com. Wait a second. Yeah, I I use c++.com/reference all the time. It's really great. Is there an app for watch people code? I tend to watch on Twitch, but you tend to check these comments more. What kind of app do you want? And like a mobile app, someone like created a web app, but I think there is I think that there is let me there are some mobile apps, but I don't think that they have chat support. But you can try with these two apps. I mean, one of them is for Android, and another one is for iOS. So you can try an app for iOS, but I don't think that it has great support for chat. I pay more attention to this chat because I think that most people watch me here. That's why I watch here. And another thing about watch people code is that this always tuned in such a way that there is virtually no lag. So you can see me lag test. Yeah, the lag is a couple of seconds. Do you have a guide in doing this? I think that, well, actually you can use WebSockets from other languages, and actually the chat uses WebSockets. Sorry, the chat uses Socket.io, and there is C++ support here. So blog, if you open blog, there is Socket.io C++ client on GitHub. So you can actually use this library to create something using chat. Clan gives me an error for const explorer. Let's try using const explorer. Oh, okay. Let's const explorer. Maybe I'm wrong, actually. Wait a second. Maybe. Okay, it works, I think. Yeah, it works. Just you need to add minus std equals to C++11. So you can actually do compile time operations here. Let's write Fibonacci. Let's write Fibonacci numbers computation. Or maybe not. Let's compute a factorial. And to check if it's possible to use, if it's actually, we can use the result of this function during compile time, we can create a template and check it. Have you tried a website like Code Wars or HackerRank to show people how to solve problems effectively? Yeah, I did a few HackerRank sessions, and I plan to do more HackerRank sessions in the future. I actually like HackerRank. Is Constacker made to stop people using templates for that kind of stuff? I think so. I hope I didn't lie to you, because I have not that much experience with C++11. Yeah, probably you. I probably did use a lot of damage. Is this out full 10? Let me check if it works. Um, Post your code. Expression is not an integral constant expression. That's surprising. I mean, statement not allowed in context per function. So, okay, this is because, yeah, okay, actually constant expression has limitations. This isn't surprising. But it can actually simplify writing code. So we can do this. Factorial and -1. I can do this. Return. Okay, it worked. Again, it has some limitations, but it can greatly simplify writing compile time expressions. I guess it will also increase performance. Then I'm pretty sure it will, but I don't know. I haven't played. I haven't played with context. What is the difference between passing arguments with angle brackets or like normal parentheses? The difference is angle brackets for template arguments, and parentheses are typically for parentheses are for normal arguments. For example, we can actually let me show you something. So template is like a template for a function or for a class. So we can have template function here. Actually, I think a template function is something I want to show you. What would be a great example of a template function, though? Sometimes you really need a template function. Let's see. I probably can't come up with a good example, so let's use something completely synthetic. Okay, it's a pretty useless function because we don't really need to use a template here, but I just want to demonstrate how I just want to demonstrate the syntax. Oops. Guys. Oops. C++ has function templates, yes. And we can actually use a template here. Again, these are two completely different types of arguments. Doesn't the type signature have to be void foo and x? Not really, but you can make something like print function. So you can use a type name here, and you don't have to use only integers as template arguments. You can have types as template arguments. So you can have something like that. So this function would work with actually, I know a great real-world example of a template function. Yes. How could I miss this? Std string y hello. So we can call it like that. Oops. But right. So these template arguments. So these two types of arguments completely unrelated. So this is just a print function, right? So here we can use type as a template argument, and this template argument. These are normal function arguments. We can actually omit them, and C++ can deduce the type from normal arguments. Yeah, I hope I'm explaining this clearly. If you, maybe I should explain it in a different way. Let me know if it's not clear. What else? Actually, there is a great real-world example of a template function. Okay, so let's say you want to write a function that calculates minimum of two numbers. So you can write minimum like for integers, right? And like if x less than y, return x, else return y. General operator, okay. And int x equals to 1, int y equals to 13, and well, we need to find a minimum of x and y. Okay, and it's 1, so we can also change the order of the argument, and it will still print 1, so the function works. But well, let's say we want to find a minimum of two doubles, right? So we now have two floating pointer numbers, and we need to find the minimum of them. And obviously we can't use, let's rename them to A and B. Obviously we can't use this function, or maybe we can. Yeah, we can, but it will output, I think it will output 20. Let's see. Yeah, 20, which isn't the same thing. This is because doubles were converted to integers. But what if we want a double version of the same function, right? What do we do? We can use for function overloading to write a version for doubles, but this isn't fun actually. Why don't we write a template function, which will be really great here. So let's make it a template. So instead of writing like 1,000 functions for each type that supports less than operator, let's just write one simple function, like a template function, and it will work. Again, here we can manually specify the type of the arguments, so we can do this, but C++ can did use the types for us, so we can just omit this. Is it integer with bit? How does flag techniques work? I mean, when I can set like, yeah, it's an integer with bitwise operations. Yeah, typically it works like that. You have a enum, and maybe not even a enum, but I would use a enum, and it's something like sum flag 1 is equals to 1, sum flag 2 is equals to this. Is equals to like 4, and so on and so on. So templates can make C++ function work more like Python. Yes, that's true. It has some similarity to duck typing. So yeah, it can be really cool. And you are right that C++ functions can work more like Python functions. That's a good way to look at this feature. So what else? So yeah, basically it's just a bunch of bits, and you just OR them. So you are correct here. How doesn't that? Okay, I already explained that. I think this. Or do you still have this problem? If so, let me check it. Int and prime. I don't think that you can use statements in const expressions, so it's still pretty limited. Just I think less limited than templates. Oops. Minus std equals to I don't know, it doesn't say anything. Wow, it compiled in C++14. Wow. I never really knew that it's possible to. Oh, that's really cool. So works for me. Okay. Apparently, is there anything you're excited for in future versions of C++? I haven't really. So the next standard is going to be C++ 17, and but I don't know. Should I be excited about it? I don't know. I haven't really looked into what they're going to include there. C++ 17 coming soon. I think Bjorn posted something about. What do you mean you removed it? I think it's still there. No? I think it is still there. I can still access it. Okay, then download it from the internet. Okay, so what's next? Oh yeah, C++ 17. I think. Yeah, I think Bjorn Straustrup did mention something about C++ 17. As for C++ 11/C++14, I'm really excited about for range loops, lambdas, auto, move semantics, like move constructors. What else? Threading support, it's nice that it's defined properly. It's really nice. There are a lot of different nice features They're like smart pointers. I don't. It's nice to see them included in core language. Well, not in core language, but just in a standard library. Okay, are you using G++ or Clang++? Um, there are local include being. Yeah, you should call Clang++ because Clang++ is a C++ compiler and Clang is just a C compiler. Return let's add a return statement here. Well, it doesn't work it doesn't work with G++, but it works with Clang, I think. At least it does compile. Okay. I think Beyond released nice things about C++ 17, and I don't think it will like his thoughts. And yeah, actually, this is a lot. This is what I was looking for. I saw this. Um, what will the C++ 17 be? It's really nice to see array view and string view. This is what I would like to see in the C++, like in the C++ standard. You can have this using libraries, but it would be awesome to have something like that in standard library. What's next? Coroutines. Well, that would be nice to see. I don't know. Personally, I don't see like huge things to be excited about. It's clearly that it's not going to be a major release like C++ 11 because C++ 11 changed a lot of things. It was like a huge leap forward, and clearly that C++ 17 is going to be like an incremental step forward, which is actually great. I think it's great that, yeah, actually this is a nice feature. I don't know. I think that C++ doesn't have normal modulus, and it would be great to see normal model support. But I don't know. I don't. It doesn't make me excited like C++ 11 did. So it's a nice step forward. It's definitely great to see the committee making small incremental steps every few years. So yeah, coroutines would be nice. I don't think I really needed coroutines with C++, but I did use coroutines in Python. So coroutines are definitely a nice feature. Uh, so, like I mentioned, it's really nice to see the standardization committee making changes every few years and not leaving the language unchanged for a decade. So, so yeah, it's great that they make a new C++ standard every few years. Oh, okay. 4 people are here. Wonder how many people are still there. Ten viewers. Wow, that's nice. Thanks for watching, by the way. Um, Again, by the way, what do you think I should include in my next C++ sessions? I really want to make them educational and stuff like that. And well, I don't know how to make. Like I mentioned, I'd like to make some sort of a course, but it's really. I don't think it's. Yeah, it returned actually. It returned something. Um, what is coroutines? Okay, the simplest way to explain what a coroutine is, I think it is this. Okay, imagine threads, and threads are typical. Like when people talk about threads, they typically talk about preemptive, like multi-threading. Uh, so how does it call preemptive concurrency or multi-threading? Yeah, I think it's. I'm not going back to this FML Tetris on Wednesday. Okay, I can do that. Yeah, I will definitely go back to Tetris. Mm, yeah, that's a good way to look at coroutines. I look at coroutines as threads, but I don't know. Maybe it's because I used Greenlit in Python. I look at coroutines as threads that do not switch automatically. So coroutines are like threads that aren't switched automatically. Okay, I really like it too. So I'm happy to do this every C++ session. So if you want, the next session is on Wednesday, I will probably return to the Tetris. So but like I mentioned, I will be happy to answer questions and to give you examples and basically do what I'm doing right now. So coroutines are great. The reason is like low overhead, and actually they reduce the necessity for synchronization, like from mutexes. Um, Yeah, if you have, by the way, if you have C questions, let me know. Maybe I should do a socket demo for you because we were talking about sockets the other day. I think we were talking about sockets yesterday. So if you want, I can do like some. I can write a netcat in C for you. Is using something like libgc is a smart thing. What is libgc? I never heard about it. Oops. So it's like a garbage collection for C++. Oh, I mean, how does it even work? That's I never heard anyone using it. an error. Yeah, yeah. I understand that templates like compile time computations using templates is a fairly advanced topic. So if you're just starting learning programming, don't be intimidated by not understanding those. It's like a really advanced topic, and it actually requires understanding like basics of functional programming. Uh, I wanted to do something advanced this day because some people want advanced stuff. I feel like some people want to see something advanced. So yeah, I don't know. Maybe I should keep like a consistent level of like maybe I should yeah like keep like maybe I should keep the level of advancements like consistent. So not do advanced session one day and like more basic sessions the, during another day on another day. I don't know. So it's the whole like C++ course is an experiment for me, and well, let's see where it leads us. Не, я нормально по-русски говорю. После английской речи, правда, иногда сложно переключиться, да. So, Yumi asked if I speak Russian in Russian with accent, or is it just post effect from switching from English? And well, it's basically a post effect uh, from when I speak English and then I switch to Russian. I don't make this switch instantaneously. It takes me a couple of seconds to adjust it. Ah. Where did you learn Russian? Ah, okay, Google Translate though. I think we had someone on IRC who knew basics of Russian. Yeah, I'm also afraid that no one wants to view advanced sessions, but I don't know, so I kind of don't know if I should make more basic sessions or I don't know. We'll see. I'm happy to explain basic stuff as well. Just ask me questions. Really? Why? Do you watch a lot of anime? Because I wanted to learn Japanese when I was watching lots of anime. Uh, but then I stopped watching anime and my desire to learn Japanese kind of vanished. Let's see what's going on RC. Nothing really new. So I think it's cool you do you have any animals? Well, I no longer watch anime, so I guess it's okay to break all the rules. Do you have any animals? No, unfortunately not. I'd like to have a cat, but I really can't because I rent an apartment. What's your relation to C++? I have 4 years program. I have 4 years of experience programming in C++ professionally. I worked in Yandex, and Yandex is a Russian company. It is most known for creating the most popular search engine in Russia. So in Russia, like 60% of people use Yandex, and like 30% of people use Google. So yeah, Yandex is the most popular. We also have a third search engine actually. called mail.ru. Um, but it's not very popular. I think that only like they have like 10% of market share. So what did I do in Yandex? I worked on a certain part of a web search engine. I can't really speak in details about it because I don't want to break non-disclosure agreements. Uh, no, I actually don't work on in the AI department. I didn't do much rocket science stuff, but it was pretty much fun working there. Like I learned a lot about C++, about software development. Um, you went to Yandex from high school? No, when I was when I was no, I started. I went to university when I was 17, and I started working in Yandex when I was 19. So, so it was after 2 years of college. Let me check chat. 5 people are watching on Twitch. That's actually cool. Thanks for watching on Twitch. I also stream on why you worked in Yandex. Now I work on my own projects. I wanted to work on my own projects, so I quit a couple of months ago. You have a no? I don't have a. I dropped out of university because one year before graduation. I still can't understand how you get hired in Yandex before college. It wasn't before college, it was during the college. And actually, in Russia, it's pretty common to start working um, during college. You just work part time. What are you doing finance wise right now? I have savings, um, well, so yeah, I can survive on that. Well, I'm not really genius, but I have lots of experience. Don't maybe I don't know maybe, but it's not easy to monetize it. Maybe I should have a donation button like on my channel or something like that. Um, I wish I will consider this career, but I think it's dangerous. Yeah, we have a lot of these things in Russia. 7 people on Twitch. Wow, I'm like the first in the programming session. That's nice. Not really. Wow, 4 likes already. Nice. So this is just a joke, guys. I don't really deal drugs for better or worse. 7 people. Stop that. Stop that. Command removed. Wow. Stop that. I mean, not stop joking. I mean, stop. Stop that. Stop doing this, YouTube. So I was speaking to YouTube, not to you, girl. But yeah, sorry. Yeah, what if? Yeah, what is like NSA monitoring this chat and like just this guy's serious? Um, I'm just kidding. CPP quiz question. Oh, I'm not. I will. It will be a lot of. I'm not going um, to take this quiz because it will be embarrassing. Yeah, but we have a casual modern version of KGB, which isn't fun. So it's not like we are safe from NSA. We have our own NSA. No, I'm being completely honest with you. I'm not working. Let me take this quiz. Uh, I will answer a couple of questions and then close it out of embarrassment. Oh, you mean these two? Oh, if I remember, I'm not really that good in C++11. I think it's a value reference. Yeah, if I remember correctly, double and percent is a value reference. Yeah, you are right. Okay, I have no idea. Okay, is same decal type int j int value is compilable and deterministic. Okay, can it be undefined? I don't think it's undefined, though. Actually, I actually don't know. Let's type um, 0 um, 0 1 okay 0 0 0. I'm probably wrong here and incorrect. Okay, let's view a hint. Yes, a really thought captured by copy. Oh, okay. Can I skip this question? Let's try another question. I'm bad at C++. 11 plus, it was a really difficult question. Okay, bye. By the way, I'm going to end the stream soon. Let me know if you have other questions. So, meanwhile, I'm just going to have some fun. Again, C++ 11 stuff. I'm not that great. So keep me entertained then. And keep your questions coming. I can probably stream for like another half an hour. Why do you use clan++ over C++? Because it's the default compiler on OS X. So if you install Xcode stuff on OS X, it will also install clan++. Yeah, I mean, C++ is a really complicated language. So if you work, even if you have professional experience, it's still difficult to answer them correctly. Let's skip this because I don't remember C++ 11 stuff. Okay, thanks. I will know that. Well, clan actually has really nice features. For example, clan has really nice options like it has a really nice architecture. It's not monolithic like GCC, so you can use like clan-based completion. in Vim, and you can't really use and you can't really separate components of G++ and like use them in other programs. For example, you can't create G++ based completion for Vim, and well, switch to C++, JavaScript, and I'm totally happy. Try Python. Actually, yeah, Python may be a better language than JavaScript. Um, JavaScript, I'm not exactly happy with JavaScript. Yes, let the Holy War begin. I've never tried PHP, like never. Okay, let me try this one. What is the output of this program? Damn it. Wow, that's interesting. Let's say it's 1. Alright, let's try 1 and 2. Damn it. 2 and 1. Damn it. 2 and 2. Wow, okay. I actually really like jQuery. I think that jQuery makes using the JavaScript a lot more easier. Yeah, I remember that. I was watching your stream, so yeah. Okay, let's see this. Okay, I have no idea what's decal type, how decal type works. I mean, I have some basic idea, but not details. Someone please write a bot. Let's see if there is something I know. Okay, this looks simple enough. Wouldn't that be 42 divided by 0? I think it would. I don't think it's. I think it's undefined behavior. Yes. Let's see if I'm correct. Yes. Integer division by 0 is undefined behavior. And it was easy question. Decrementing is this. It decrements variable by 1, so it reduces. It would compile. It will compile, but the result of the program is undefined. Basically, undefined is a very interesting concept in C++, and how does it know which variable? Well, it knows that minus g. It sort of somehow parses it, and it somehow knows it. So this is like decrement for j. If j minus mass, would it be 42? Yes, it would be 42. It would be defined. Okay, so yeah, makes sense. So what is undefined behavior? And the defined behavior is a very interesting concept in C++. Basically, it means that sometimes And the standard says something, something, something. If you do this, result is undefined. And basically, what it and undefined behavior means this: if undefined behavior, like um, if you do something that causes undefined behavior, your program can literally do anything it wants. Um, it can, format your disk, I don't know, mail your boss or whatever. Of course, in real world, this isn't what happens. And in real world, undefined behavior is like this defined slash specified slash unspecified slash undefined behavior is is a concept that helps compilers optimize the code. And so basically, this means that the program that is the the result of this program is undefined, which means that it can do anything. It can print hello world. It can literally undefined. Compiler can generate whatever code it wants. Of course, it won't ever print hello world, but it will do weird shit. So sometimes it may simply crash, and when the decrement is before variable, doesn't it use current value then decrement after? So wouldn't it be 41 divided by 1? It's the other way around. I mean, minus minus g does two things. It decrements variable and it returns the new value. And j minus minus does something different. It decrements variable and it returns the original value. So let me show it. X equals to 42 and y equals to 42, x minus minus. Okay, so here's how it works. As you can see, my postfix decrements variable, and then returns its original value. Whereas prefix decrements a variable and returns its new value. So that's why I divided by j minus minus is equals to 42, and y divided by minus minus j is undefined behavior. So yeah, I agree. Thinking in C++ is great. Okay, let me try a next question, and I will. According to C++ language standard, what is the output of this program? Bar. Correct. Yeah, so default arguments are evaluated each time the function is called. In Python, it's different. In Python, that would be evaluated only once, and in C++, arguments are evaluated on each call. According to the C++ 11 standard, what is the output of this program? I'm pretty sure it's 20. It should be 20. Yes. And yeah, there is the explanation. The comma operator is applied. So this is a comma operator. It is rarely used, at least in my experience. And basically, it does two things. It sort of evaluates each expression, and the result of the comma operator is just the right operand. Although you can have multiple commas, like A, comma B, comma C, comma D. Let's take an expression. Let's see. Never used comma operator in production code. I've only seen it as a bug. I think sometimes it's useful when you are doing loops. So something like that. So something like that is occasionally useful, and I know I think sometimes comma is useful, but yeah, I agree it's rarely used. I think the only time I saw comma in production code was like something like for loops. Call idle. Idle as something. Idle t. Wow, that's actually really interesting. So idle is a template function that also has a non-template. Well, there is a difference. So basically, there is template function with the name idle, and there is another function with the name idle that takes one argument s, and this takes like a template argument t. And basically they are overloaded. So what happens when we execute this function, which has a template parameter? My guess that this function is called both times. So it doesn't matter if we do idle as constructor or idle t when like with this. I'm pretty sure that both times, but I'm pretty sure that the correct answer is SS. But C++ is a weird language, so I'm not. So I mean, it's a weird language. Let's see. And I'm wrong. Okay. So is it st? Again, is it both time tt? Okay. Maybe it won't compile. Maybe it's not compile. Yes, maybe it has compilation error. So I don't know. Let's view a hint. Unqualified names are resolved at different times depending on whether they are dependent or independent on a template parameter. But I already tried st. I mean, I tried st. I tried ss, I tried st, and okay, I gave up. Show me and the answer. The output is ts. Oh my god. Oh, it's ts. Why? Oh my god. So it's not ss. Holy shit. That's just horrible. So it's not ss. It's ts. Okay. I'm not going to explain this. I mean, I think the explanation is clear enough. There is another question. Where can I click for another question? Okay, let's try another question. According to the C++ listener, what is the output of this program? A, B, C. I don't remember the specifics of auto, so I think obviously the default constructor is being called two times. Then something in between, and then cc. It doesn't matter that the function is virtual. We can. I'm pretty sure that it's AAA and then CC. The question is whether auto here, whether the type of X here is deduced as a reference or it is just A. So the question is whether it copies things or not. That's this is and if I remember correctly, just auto X discards references. So even if iterator, the reference on iterator returns reference, I'm pretty sure that it's going to be discarded. So it's A, B, B, C, C. Maybe I'm wrong. Let's see. Okay, I don't want a hint. I just want to try it. No, I'm wrong. Okay, is it AACC? That's surprising, actually. Okay, I want a hint. So now I want a hint. Apparently, I shouldn't try answering C++ 11 questions. Okay, let's do a hint. When the array elements initialize, what is the difference between auto and auto reference? Okay, so when are array elements initialized? Well, I don't know. I think that they're initialized here. So it should be AA, BB, CC. Okay, I don't know. Let's. I give up. Show me. Make one more 10 first. Loops are executed one after another. So, is it ABC, ABC? No. I give up. Show me the answer. Okay, let's see. A, B, C. Oh, holy shit. You are right. So close. I'm dumb. This is really dumb. This was really dumb. Obviously, that it copies first and then it does functional. Oh, I'm dumb. I was really close and I just really did a dumb mistake. It's obviously that it's A, B, C, B, C. I don't know, I thought it should be A, B, B, C, C because like when I look at this and I realize my mistake and I think like, oh my god, I'm so dumb. And I just remembered, and I remembered correctly that auto sort of mm, like if X has, for example, if X has type, sorry, if iterator returns the reference, an iterator returns a reference, auto will sort of discard it. So I knew the difference between auto and auto reference. Oh. But was so embarrassing because it's just like a normal execution flow, and well, this is just so embarrassing. Okay, let's try another question. I hope you guys enjoy this, but basically I wanted to end the stream. I wanted to end the stream a couple, like I think, like yeah, you got me hooked with the quiz. So let me try a couple more questions and I will end the stream, especially to save my face. And yeah, it's right. It's not a difficult question. I don't really want to deal with it. I need to read Scott Myers' book first. Okay, this is really easy. I think I know that it's 20. Oh, real quick. Okay, so what is arrow operator? Yeah, let's say we have. That's really simple. Arrow operator B is the same thing as. I'm not going to write a code, but if you want, I can. If you want, I can show you a demo. So basically, when you access a member of a struct, or if you, so it's not 20. It's compilable and deterministic. No, it's incorrect. Then it doesn't compile. Oh, maybe it does compile. Oh, it depends on precedence. I don't remember what has higher priority, equals or comma. I mean, if equals has higher priority, then it's going to be 10. Yeah, okay. The comma operator has the lowest precedence of all C++ operators. And yeah, it has lower precedence than equals. Let's try another one. x are 1, y y1 are 0 equals to y1, print y1, print r0. Okay, let's see. So we have two classes. One of them is inherited from another, and we have a virtual function f that does some printing. And well, in Russian it is y, but I think that English-speaking people tend to pronounce y as y, not as y. So y. So I'm pretty sure that x has type, so r0 has type x, so this should be yx. So right, first y1 is print y1 is called, which does this const reference that's actually interesting. Isn't epsilon a Greek letter? So I mean, we pronounce this letter as epsilon, and we pronounce this letter as y. Okay, my guess is it is yx. First, y1, print y1 is called, then print r0 is called. Correct. Yes, I was right. That's nice. So there is type def lon ll and unsigned ll, and there is holy shit. So what happened? We were discussing the pronunciation of y letter, because in Russian we don't say y, we say y, because it's like a Latin alphabet, not like English alphabet. So we say y instead of y, and we started discussing why, like how y is pronounced in different languages. For example, in Dutch, it can be pronounced in a similar way, I guess, but also epsilon. But in Russian, epsilon is a Greek letter, well, which looks weirdly like that. I think I showed it like that. So I don't think that compiles. Maybe I'm wrong. Incorrect. Well, C++ is fucking complicated language. So it's compilable, unspecified, undefined. How do you type English on a Russian keyboard? Well, we have two keyboards. So, okay, actually I'm just joking. We have both keys on yeah, it looks pretty much like that. So here's like Russian layout, and we switch between different layouts by pressing a key combination. How do you type Russian on an English keyboard? I'm a touch typist, so I can type Russian on any keyboard. You just need to select a layout in your configuration, like in your system configuration. So I can use two layouts here, and I switch between them by pressing caps lock. Is compilable and deterministic? Okay, my guess is that it outputs 2. Yes. Oh shit, that's actually interesting. I mean, yeah, it's actually obvious. Yeah, I get it. I definitely sensed that there is something wrong with this unsigned declaration. I felt like it should, like, I had that feeling that it should be a separate type, like in somewhere in the back of my mind. So, but I didn't realize that LL can mean a name, and now it's really obvious. Yeah, I agree. That was my first thought too. I mean, it looked like nested. I didn't felt like type def declaration. I felt like type def declaration. You can't really put unsigned after before LL, like that. But at the same time, I just thought, okay, maybe you can, and like maybe it looked ambiguous. Yeah. What is a long type? It's 64-bit. Well, actually, I think that C++ standard doesn't really mention the size of a type, but normally long is like no. That's a good question. I think long is 64-bit long on most machines, and long is just the same as int. I'm not sure. Let's see. Let's type. Yeah, it depends on the architecture. I think that C++ standard doesn't really mention the actual sizes of types, but normally long is 64-bit long. And let's just try. No, I don't think C++. I don't think modern processors support. Maybe I'm wrong. I don't think that there is 128-bit integers. What the hell? Oh, yeah. Let's just. So, okay, long is actually the same as long. And yeah, okay. But like I mentioned, C++ standard doesn't actually say that int should be 4-bit long, and long should be like 84-bit long. I think that it mentions that something like that. Size of long is more or equal to size of long, which is in turn more than equal to this is not a C++ expression, by the way. I mean it is, but I don't mean it to be a C++ expression. It is in turn something like that. Okay, let me try another. According to the C++ learner standard, what is the output of this program? I think the output is 347. Oh, wait a second. Actually, it's a. I think it's undefined behavior. Maybe I'm wrong. I'm correct. It's defined behavior. Okay. Maybe it's unspecified. I still can't believe this is defined behavior. Oh, maybe it won't compile. Yeah. But wait a second. It probably can. I'm dumb. It probably can. Again. Wow, it's compilable and deterministic. This is weird. Okay, I guess let's try. Bye. Okay, see you again. I'm pretty sure that most people don't watch me attempting this quiz. I actually don't want. And wow, 13 viewers. Where did you come from? I feel like I'm really embarrassed because let me brush up on aliasing. I definitely need to read about pointer aliasing. I thought that pointer aliasing causes undefined behavior. What question number is it? It's somehow I did. Oh, what the hell? You have 0 points. I don't think. Why do I have at 0 points? Maybe I refreshed it. I don't know. It's question number 9. No, it's not 1, 2, 2. I'm pretty sure that it's like 4, 2, 8. If it's compilable and deterministic, it should be 4, 2, 8. Okay. That's surprising. I will read about pointer aliasing. I thought that it should be similar. Okay, so BA. Wait a second. No, BA. So first, since two classes are inherited from one another, so the first thing that gets executed is the y for. What was the number of this question? Okay, I can explain that. So. Oh, okay. You have answered 7 out of 61 questions correctly. Basically, because this is a reference. And the way reference work is. How do I explain it actually? Basically, references are somewhat similar to pointers. If you have some experience using Java, I think that you should understand references. I mean, they have some similarity. So basically, this isn't a declaration of a new variable. Instead, and how do I explain references to people? So this isn't like a normal variable, it's a reference. And whenever, and reference can reference an object, right? And when you access a reference, this object is going to be accessed. Why? Okay, well, you understand. Perfect. This makes really easy to explain. Um, so basically, it has it's called AA. So here, first A becomes 3, and not this A because this is just a reference. This A becomes 3. Then this is B, and it still points to this A. So then this A becomes 4, and then return A plus B returns 4, because both A and B reference the same object. It still references, both reference this A, which is 4 at this point. So yeah, B isn't accessed at all, so that's why B is 2 here, A is 4, and well, C is the result of this function, which is 4. Okay, let's try it. Did I fuck this up? Let's try it. Did I get it right? Yes, I get it right. And yeah, I'm pretty sure that the explanation is like better than what I would explain. I don't get why it's why it is a medium difficulty question. I think it's fairly easy question, at least for me. Oh, okay, it's a different question. The first one I don't remember what it was. Okay, extern C int x, extern C int y. Okay, I have no idea. Okay, it has a compilation error. Let's try it. Okay, I was correct. What is an extern? Like, I have no idea how to explain extern. The only use for, like, the only use of extern I ever encountered is for interface between C++ and C code, and I don't really. Oh no! Sometimes you need to extern global for global variables. Okay, there are 2 uses of extern that I haven't had. I don't feel like explaining this because I very rarely use extern. So okay, I think we saw this one. It was TS. Maybe I'm wrong though. Okay, correct. This is because we saw that one. Okay, it's advanced. It's difficult question. Let's skip it. Okay, where's another question? Okay, I don't remember how async works. Okay. Did you ever go to Codeby? Not really. I should probably check it. Nice question. I think it should be 1, 2. Because this is a normal constructor, and well, vector has like a normal constructor which takes 2 parameters like size and default value. But this is I'm pretty sure this is a syntax for coding that creates like std initializer list. Maybe I'm wrong. Let's see, because I was wrong so many times. So let's try it. Yes, okay, I was right this time. To answer this, we need to look at the overloaded resolution vector constructors. Yeah, I was right. There is the construct that constructs vector with n copies of value. So v1 contains 1, 2. Okay. So v2 is initialized from the elements kind initialized clauses in the brace net list and contains the elements 1 and 2. Okay, let's take and look at another code. According to the zip, oh my god. Is it 1? So I'm wrong here. It's not 1. Okay, it's 1. The template function will be instantiated as void f int. Okay. That's great. I was right. I mean, I thought that it's either 1 or compilation error. So it's either 1 because yeah, it's a better match than because I thought it's a better match than const int reference. So it's either that or compilation error, and I thought that well, it should compile because it's just a partial specialization. So I tried 1, and I was right. But this quiz is really difficult. This is compilable and deterministic. So I think that unspecified. I'm wrong. Maybe I'm wrong. So it's either. That's a good question. Basically, we have this instance of A, this instance of C, and this instance of B. Oh my god. So I'm pretty sure that when the constructor of B is called, A is already initialized. So it's already constructed. As for static C, it's a static one. And my guess is that it's either unspecified or so a compiler can choose to first initialize A, then initialize C, or maybe first initialize C, then initialize A, then launch my function, and well, good stuff happens. Or maybe it's compilable and deterministic. Okay, let me guess. My bet is it's compilable and deterministic, and it prints A, B, C, B, C, A. Let me guess. So A, B, C, B, C, A. Yeah, let me guess. Correct. Yes, I guessed correctly. So next question. Okay, it either has a compilation error or it's undefined behavior. And my bet it's undefined behavior. Maybe I'm wrong though. Incorrect. Okay, let's try has a compilation error. Incorrect. So it's neither compilation error nor it undefined. I don't know. That would be a weird feature. Oh, that's a weird corner of. So okay, I guess it's true. No. Okay. What's the address of the stack? Um. Okay, give me a hint. At which point in the name program is the name piece declared? Okay, that's not really helpful. I give up, show me the answer. The answer is compatible and deterministic, its output is 1. Okay, I actually didn't realize that bool is output as 1. That's interesting. My third try was this. You started logging from to me. Oh, you mean FPS? Let me take a look. If there is a problem with FPS, maybe I could just lower bitrate. Let's lower the bitrate a little bit. Okay, let's try another question. Okay, 2 more questions and I will end the stream because I'm tired. Yeah, it's okay. Bye. It was fun too. So 2 more questions and I will end the stream because it's almost 2 a.m. here. And okay, let me try this. BB, GB. So the answer is B. Correct. It's probably a compilation error because notice the quotes. No, that's weird. So it's not a compilation error. Okay, let's try this. Can it be converted to a? Can somehow a const char array be converted into a just a char? Let's just check one. Okay, incorrect. Maybe it's undefined. Then using toString. Okay, I got it. We are trying to initialize a vector char using toString literals, not two chars. Okay, I understood this correctly. The problem does, however, not result in compiler error. So I was right until this point. So I was right until See you Wednesday too. So yeah, I was right until this point. Oh, holy shit. Going back, we find this candidate. You already use standard string. This isn't standard string, it's const char, array of n const char. And turns out that this constructor is called. For some reason, it's a match. Okay, one more question and I'm ending the stream. I think I saw this one. Let's try another one because, well, I just answered that and I saw this one as well. So let's try a new question. The output is 0, even though it's not initialized to anything. So it kind of looks like undefined behavior. If I remember correctly, it is initialized to 0. So the answer is 0. Because it's declared as like here, it's not in this variable. Yeah, I'm right. Okay, so I'm ending the stream. Let me check chats to see if there are any questions. Hi, sorry. Sorry, I wasn't paying enough attention to this. To Twitch chat. Oh, no questions. Okay. Thank you for watching. Good night. See you again on Wednesday. Although I will stream something tomorrow or the day after tomorrow, just probably not C++. Thank you very much for watching.